Hi, welcome to the Microscopy 101 channel, and today I'm going to talk about digital cameras, specifically the white balance setting or color correction. So frequently when we collect images on the microscope, we would like the images to be as we see them down the eyepiece, and frequently these images may be the wrong color, and it's a common complaint for digital cameras, particularly on microscopes. So I'm going to talk a bit about how we get the right setting for that. Now, I'm making some assumptions. We've talked in another talk about exposure, and we won't be covering that today. And I'm assuming that you've got some microscopy knowledge and that you've used microscopes before. So the issue with the white balance is that the color camera has got effectively three chips or three sensors. Now, when we look at the image, we would like the image to be exposed correctly, and this is going to be helped by understanding the histogram. So the histogram is a snapshot of the image. On the left we have black pixels, and on the right we have white pixels, and the vertical scale is frequency. So for every point in the image we take a measurement of the color or the gray scale, and we put it into a histogram. We do the same if we use a color camera. We then have three histograms. Now what I've done is I've set up an image here using Zen. I've switched the camera into black and white mode so that we can understand what's going on here. And you can see we've got a histogram. The histogram is showing us the distribution of the light in the image. And it's a live image. I can move it around and do stuff. And you realise if I go here to an area where there isn't much sample, the histogram peak is pretty much a single or a range of grey levels due to the shading. If I were to increase the brightness, then it increases one way, and if I reduce the brightness, the image goes to the left. Show you that again. So if I turn the light down, the histogram goes to the left. If I turn the light up, the histogram goes to the right. So the right hand side is brightness. In fact, we can see that here with the image. So I turn it down, the histogram goes to the left, the image gets darker. Turn it to the right, image gets brighter. Now that's okay for black and white, but let's go and have a look at this in colour. So I'll switch this camera into the colour mode. Down here we're now back into colour, and if we have a look at the histogram now, well, you can see it's sort of all gone wrong really. The histogram is not aligned. The three peaks are not aligned, and in fact the red is ahead of everything. You can see there's sort of more red, and that's shown if you look at the image. It's got a sort of pink tint to it. So to get rid of this, we need to realign the peaks, and there's a handy button here to do that, and if I just press the auto button, you'll see that the three peaks will align. I'll press it on this screen. Too much technology here. And you see the picture has now gone to basically a grey image. It's still colour, but because we've got the RGB aligned, the image appears to be grey. Now this means when I go back to my sample, over here we have a nice grey background and a correct coloured sample. Now there is something else that affects the colour as we see it, and this is gamma. Gamma control just to explain a little bit about that, in that we can move the gamma, and this will change the contrast of the picture. I'm going to cover this in a separate discussion, but a gamma of around about 0.45 or 0.5 seems to be the accepted norm for us humans to look at pictures, as the cameras tend to work with a linear gamma, but we work with a non-linear gamma of about 0.45. But I'll cover that in a separate talk. So to summarize, we need to look at the histogram, and we need to align the peaks. And generally you need to do this with a good exposed image. So the process is to expose the image correctly, then we can come and look at the colour distribution using the histogram. We would go, as we did there, to a neutral area where we can find something which is just a neutral background, where we would align the peaks. Now, a very important point here is that if you're using a halogen bulb, that colour correction is only correct at that voltage. When you change the brightness, the colour balance will change, because this is due to the nature of a halogen bulb, in that it gives out different colours at different temperatures. So you can see here, if I turn the light down, the image has gone dark, but look what it's done to the histogram. The colours are all mixed up again. And if I go the other way, might not get away with it here, but the image will tend to go to blue if you turn the brightness up, and the image will go to a yellow when you turn it down. So once you've done the exposure and you've set the white balance, you need to leave that white balance, leave the brightness at that position. If you start changing the brightness, you'll change the white balance or the colour balance, and you'll have to do it again. Here we did it using a part of the sample. That's quite an acceptable way to do it. Or you can take the sample away, just use a neutral colour, but then you're changing the brightness as well, possibly. So I prefer to do it using the sample and find an area on the sample that is neutral or white, and use that to do the white balance. You can also use a picker. In a lot of softwares you can move around and you can pick an area which you define as white, and that will change the colour balance of the camera. I hope that was useful, short and sharp. If you need any more information, have a look on our website. There's some resources there for additional training.